And welcome to part 3 of 6.1. Let's actually look at a few examples. Have this handy while we do the example so you can see how we use this line to graph the parabolas. So again, the key is going to be figuring out what p is from this 4p thing. So let's actually look at an example, and then I think you'll get a hang of how to do this. So it says, in this example, find the focus, directrix, and axis for the parabola. So here we go. We're going to graph all of these things for this parabola and then graph them in this little graph down here. So the first thing to do is first it's important to notice that this is a parabola. And the reason it's a parabola is because only one of the two variables is being squared. So either only the y is being squared or only the x is being squared. And in this case, it's the x being squared. So that tells us it's a parabola. Now, does it open up, down, left, or right? Notice here that we have y equals x being squared. So we have the x being squared, and it's kind of like y equals x squared. Do you see that? And that's the parabola you're familiar with, y equals x squared. So that tells me it's opening up or down. And because the number in front of x and this number, they're both positive, that tells us it's going to open up because it's positive. So it opens up, and that's the first thing to figure out. Now, second thing to do is to find the vertex, which is not too bad because you just have to flip the signs of the two numbers, h and k. So the vertex is going to be positive 2, negative 3. So there's our vertex, positive 2, negative 3. In fact, let's graph that. There it is right there. So there's our vertex, and it's going to open up. Okay, the next thing to do is to figure out what p is, because from p, we're going to find the directrix, and we're going to find the vertex. Okay, so let's think about how we can do that. Notice if you look back, I put the paper down, but remember this term right here in front of the y plus 3, this number here is 4p. In other words, this 16 is the same thing as 4 times whatever p is. And so in other words, 4p is equal to 16. And now you can just solve that equation to find out what p is. And the reason this is a 4 is because that's just the nature of how parabolas work. So divide by 4, we're going to get p is equal to 4. Okay? So that's important. You just take the number that's in front of here, in front of the term that's not being squared. You take that and you just divide it by 4 to get your p value. So, how do we find the focus now? Remember, the focus is this many spaces away from the vertex. And so the question is it up, down, left, or right? And here's how you figure it out. The focus, remember, is inside of the parabola. And so it's going to be in the direction that the parabola is opening. So if our parabola is opening up, then that means our focus is 4 spaces, in this case, 4 spaces, 1, 2, 3, 4. Whoops, I'm off by 1. It's up 4 spaces from our vertex. There it is. Okay, and so, in fact, let's put down the coordinates of that. In this example, the focus is the point 2, 1. So, start at the vertex, move this many spaces in the direction that your parabola is opening. Now, how do we find the directrix? Notice that the focus is a point, the directrix is a line, and it's just the opposite direction from the vertex as the focus is. So to find the directrix, we just go down 4 spaces. And remember, that's a line. It's not a point. So let's just kind of draw on that line right there. Now, so we've got our focus, we've got our vertex, and our directrix. In fact, what is this? It's horizontal, so the directrix is going to be y equals, and we're 1, 2, 3, 4, 5, 6, 7 spaces down. So the directrix is the equation y equals negative 7, which is the equation of this line right here. Notice that if our parabola is opening up and down, our directrix is going to be horizontal, which is y equals. If the parabola is opening left or right, the directrix is going to be vertical, which is going to be x equals. So now we need to try to find 2 points on this parabola, and this sometimes is a little tricky. One way to do it is to go back to the original equation and divide by whatever number is right there. So if you divide by 16, you're going to get 1 over 16 times x minus 2 squared equals y plus 3. So see what I did there? I just divided both sides by 16. And now 1 over 16, now that it's multiplying the square side, tells you you're going to go over 1 up 1/16, over 2 up 4 divided by 16, over 3 up 9 divided by 16. So one way to do it is just to keep doing that to try to find a point that's going to make sense, because remember it's over 1, over 4, over 9, over 16, over 25, and so on. And so that would be one way to do it, but there's actually a slightly easier way to do it. And that is, what we're going to try to do is, well, let's actually do this that way I just described for this example. So remember, it's over 1, up 4, up 9, up 16. So each one of these numbers, 1, 4, 9, 16, is being divided by 16. And at 16, we actually get 1. So that means that from here, it's going to be over 4 up 1. Over 4 up 1. Because normally it would be over 4 up 16, but it's over 4 up 16 divided by 16, which is just going to be 1. And so that's how you would graph it. So let's go ahead and draw that graph in. And that would be our parabola. So that's maybe the easiest way to do it. And remember, the whole point of finding the focus on the directrix is if you draw a line straight from the focus to the parabola, the length of that line is equal to the length straight down perpendicular to the parabola. And that's what gives a parabola its shape. Likewise, if we were to draw this line right here from the vertex straight to the parabola, straight down to the directrix, those two lines would be the exact same length. And I should put 2 hashes because it might be different than this one. But here's the graph of your parabola, and that's how you put it all together. So hopefully that makes sense. Let's do another example. So in this example, it's y minus 4 squared equals 12 times x minus 2. So again, it's a parabola because only y is being squared and x isn't. So does it open up, down, left, or right? Well, it is opening, well, we see that y is being squared. Y is being squared. That's kind of weird, right? X equals y squared. So that means it's going to be left or right. And because everything is positive, that means we're going to be opening in the positive direction. So we're going to open right. Okie dokie. Let's graph our vertex. The vertex is still going to be flipped to 2 signs. So the vertex is still 2, 4. Because it's 2 and 4, you just flip them. So that point is right here. It's the first point on our graph. Now, let's figure out what p is. Remember, this term in front of x minus 2 is equal to 4p. So that tells you that p is going to equal 3. Because 3 times 4 is 12. So that means that because we're opening to the right, that means that we're going to move 3 spaces to the right, and there's our focus. So the focus is at 1, 2, 3, 4, 5, 1, 2, 3, 4. So the focus is at 5, 4. The directrix is going to be the same distance to the left, 1, 2, 3, and it's going to be a vertical line this time because it's y squared. There's our directrix. And that is going to be the equation. It's going to be x equals this time. And it's going to be x equals negative 1. So there's your directrix right there. The line x equals negative 1. So now we can just graph it. And so again, if you divided both sides by 12, it would be 1 over 12 y minus 4 squared equals x minus 2. So it's going to be up 1 over 1, up 4, up 2 over 4, up 3 over 9, up 4 over 16. But each time it's going to be divided by 12. So that's going to be tricky because I'm not sure what value is eventually going to be divided by 12. So let me show you another way of doing this. Remember, the key here is that the distance to the focus and to the directrix is the same. So what we want to try to do is count the distance from the directrix to the focus, which is 1, 2, 3, 4, 5, 6, which makes sense because that would be basically just 2 times p. So this length is 6. And so if we went 6 exactly to the right or left, 1, 2, 3, 4, 5, 6, do you see what happens? We get 6, 6. Or if we went down, it'd be 1, 2, 3, 4, 5, 6, 6. And so those two distances would be the same. So one way to find two easy points without trying to do the math is just to go up and down, in this case, an equal distance from the focus to the directrix. Because what that means is that this distance, which is 6, is going to equal the distance at a right angle to the directrix, which is also 6. And so in this case, the distance 2 times this would be 8. So we would go over 8 and over 8, which would equal the distance going down 8. Hopefully these two examples make sense to you. And we're going to do a few more and then wrap up 6.1, so I will see you in the next part. See you there.